All right, guys, welcome to your class for the day. Just give me a second to do attendance real quick. All right, it looks like everybody's here. As you can see on the screen, we're just congruent figures and proofs. This will be kind of different, so if you have questions, write them down, keep them in mind, because we'll talk about it again, one-on-one. All right, here we go. So remember, what does it mean for two objects to be congruent? So if we're talking about two segments, obviously the two segments are equal in length. So E and F and H and G have the same length, and A, B, and C, D have the same length. When we're talking about angles, that means the two angles are equal. The measure of the two angles are equal. Okay. Now we're going to talk about triangles here. So what does it mean when two triangles are congruent? I'm sure you know this one already, but if you don't, just give yourself a second to figure it out. So congruent triangles, what we're going to say is two triangles are said to be congruent if either of the triangles can be picked up, manipulated through space by their flips or rotations, and set back on top of each other, and they match up perfectly. Well, what does that look like, I guess? So we have triangle ABC, triangle PQR. If we just manipulate QPR through space, we can put the Q on the B, move the P to the A, and the R to the C, and those are two triangles. Makes sense, should be reviewed from before in geometry probably. Pretty easy stuff. Alright, so now let's get into where we're trying to go, which is we're starting proof techniques now. So let's move on to that. So some rules for triangle congruency. This is some important stuff to write down or to just know if you don't know it already. So the first rule for triangle congruency is side, side, side. So if we have three sides being congruent, then we have the two triangles must be congruent to each other. Same thing with side, angle, side. So if two sides are congruent and the angle between them are congruent, then we can say the two triangles are congruent. And then we have angle, side, angle. So if the angle, the side, and the angle, if those are congruent, the two triangles are congruent. And you get the point. You can go through the rest of them. So angle, angle, side, same thing. Right, RHS is kind of what I use for right triangles. It's the same as the other ones. It's just something special for right triangles, right? So if we look down at the bottom here, we have side, side angles not sufficient for congruency. So if you look at this drawing right here, there's this green arc growing through this line. So we can actually make two triangles with a side length of 11 and a side length 6 and an angle measure of 30. So if we have side, side angle, it does not mean that two triangles are congruent because we can make a different triangle with that side length. Okay, that's probably a lot. So if you need to write anything down or do anything there, just take your time. You can pause the video now. You can't pause me in class, but you can pause the video. All right, moving on. All right, so now we're going to try to use those properties to show some various things. So the first thing we're going to do is show line segment AB is congruent to line segment BC. So AB is this side right here, BC is this side. So how do we do that? Well, first we're given some initial things in the problem. Generally, you'll see a two-column proof table. You've probably seen these before in geometry. If you haven't, that's fine. We'll talk about it again today. So statement on this side and a reason on this side, right? So the first thing we're given is line segment AD is congruent to line segment DC, and that's represented by the tick marks down here. So these two are congruent. And then we have also line segment DB is perpendicular to line segment DC. So DB, the one going up down the middle there, is perpendicular to DC. Really, it should say AC there, but it's fine. Okay, now that we know that, what can you think we can determine? Well, this one is obvious, right? So angle BDA is congruent to angle BDC. That's given to us how? If you know it, great. If not, it's given to us by straight angles. We talked about this one before. That's pretty an easy one. But also right angles because we know the perpendicular. But we know they're congruent because of straight angles. Okay? Makes sense? And then the really easy one here is we notice that BD, the line segment, it's similar to itself, or sorry, congruent to itself because reflexive property, right? Okay, so now we know a side, an angle, and a side, right? So now that we have proved that these two triangles are, in fact, congruent by the side angle side theorem. And since we have that, we could say that line segment AB is congruent to line segment BC because corresponding parts of congruent triangles are congruent. Okay, so that's generally how proof strategies will go in this section of the notes and this section of the homework. So make sure that makes sense. If you don't understand something, ask. The important thing to note in this section is that proof strategies will change with each problem. So just because these are the given steps in this one does not mean it's the exact same steps you'll take every time. They're going to change generally every time. Okay, let's do another example. So we have this big triangle. Show that line segment BM, so that's this one right here, is congruent to BN. Okay, so let's set up our proof table. So we're given two things again. This is generally how this will start every time. You'll be given two things, or maybe three things, depends on the problem, I guess. So the first thing we're given is angle A is congruent to angle C. Don't make fun of these angle symbols too much. I made these in PowerPoint. Okay, what's the other thing we're given? I guess we're given that line segment AM is congruent to CN. Well, that's good. If you could tell where we're going right now, we're trying to get, we need to find these, right? So we need to determine if these two triangles are congruent. So we're going to try to make an argument about these two outside segments. Okay, so the first thing we're going to notice, we already got it, because if you look at this big triangle on the outside, right? So if you look at BAC, since these two angles down here, angle A and angle C, are congruent, we can say the whole big triangle is isosceles. So remember, because we have the two angles are congruent, so we can say the whole thing is isosceles. So that means that line segment BC is congruent to line segment AB, which is perfect, because then we can say the two outside triangles, triangle AMB and CNB, sorry, are congruent by the side angle side theorem. From here, you're home free, because then you could say that line segment BN is congruent to BM because corresponding parts. Okay, so I got a lot of empty spaces there just in case we did some other method. And just because I use this method does not mean there's not a different way to solve this one. There might be, but maybe not this one, but sometimes there's alternate routes to the proof. Okay. We're going to do the last one now. So, all right, maybe you want to I'll get the next two going here. So you know that line segment DC is parallel to the line segment AB. So that's DC, AB, those are parallel. That's great. We also know that DC is congruent to AB. That's also great. So if you want, pause the video. Maybe try to do this one by yourself if you can. If not, that's fine. You can move along with me at the same pace. Whatever you think, but give it a try if you want. Alright, so what do we know? We know that these are parallel lines DC and AB, right? And they're cut by this transversal, AC. And what do we know about transversals? We know that the alternate interior angles are congruent. So we know that angle DCA is congruent to angle BAC by alternate interior angles. That's great. Where are we going with this? We're going to do side angle side because we know that line segment CA is congruent to line segment CA because of reflexivity or reflexive property. That's great because then we know we're trying to show the triangles are congruent this time, and that does indeed show up by side angle side theorem. All right. Hopefully, if you did it by yourself, you wound up at the same place I did. If not, if you went a different route, that's fine too. But here's your homework. You're going to love it. 1 through 22, page 72. Yeah. Bring your questions to me in class. Thanks for paying attention, guys. Have a good day.